The dependent variable, or CTQ as it's often called, has a lower spec, a target, and an upper spec. We're also able to specify a tolerance, as well as a sigma value, or Z as it's often called. In turn, the tolerance, as well as a Z, determines the magnitude of sigma for purposes of a Monte Carlo simulation. Now, corresponding to that line item showing here of the CTQ, we have the ability to manipulate the Z value over here on the right. We'll notice we can grab the little bar right there, and as we move that bar, we can see that the standard deviation changes, and it's changing because the Z value changes. It is this standard deviation coupled with the mean that drives the Monte Carlo simulation. We can also specify the tolerance bandwidth, and as we see, as the tolerance bandwidth changes, the standard deviation also changes. So we can get a change in the standard deviation by directly altering the corresponding sigma value, sigma capability, or Z value as it's often called, as well as inflating or deflating the tolerance. We can also manipulate the target value. So with this simulator, we have great control over the various parameters needed to set up and run a Monte Carlo. Next, I'd like to call your attention to the 8 independent variables marked in blue as A through H. Again, the same applies. We have the Z value that will change the standard deviation. So if we believe that we're running about 5 sigma, we can dial that in right to 5 sigma and find that our standard deviation is 13.8. We can also again change the tolerance. So if we change the tolerance to 35% tolerance zone, which would be 300 target plus or minus 35% of that, that provides us a sigma of 21. Now, to make this simulation run, where Y is a function of A through H. Now to start the process, all we do is hit this button. At any time, we can restore the default settings by hitting the Restore Defaults button. A little comes up and says, hey, you've done it successfully. So we're back to the original conditions. Now to start the process, we simply click that button, and we're going to get a warning. All the data that you had in the previous simulation will be deleted. Is it okay to continue? Just hit yes. So in this particular case, I only want to see the continuous data and none of the inputs, because we're going to do a little characterization study. I'm going to opt for 300 observations. Matter of fact, we could take that down to, for example, to 150. Any number of observations that we want to put in there. I simply hit OK, and now it's happily generating 150 samples, emulating operating that process over 150 cycles. So there we have our data. Now, easily enough, I simply copy that data in Excel, and I'm going to move that over to Minitab. Paste it in, and simply label that column the CTQ, or I could simply call it Y. Now, to run the capability study, I'm moving over to Capability Analysis, selecting for continuous data, and it asks me if my data are in one column. They are. And which column? I simply click in CTQ. It says, how are your subgroups defined? And in this particular case, it's 1. Now I input the lower specification limit, which in this case was 520. And now we input our lower spec and our upper spec at 1080 and put our target value in of 800. Simply hitting OK. What I'm looking at is the lower spec and the upper spec and the performance of that process across 150 parts. And now we've taken a look at the SSMI Process Characterization Simulator, how it works, what all the knobs, dials, and switches turns, how we can integrate that data over into Minitab, do the analysis, which leads us to further exploration. Thank you very much.